Theme: Simulation of thermal process model for pressure tight unit. Let's simulate the model of the tight unit for calculation of integral and temperatures of printed circuit assembly and radio frequency components. The following parameters of the unit design are set. The sizes of the unit: length 250 mm, width 200 mm, height 300. In the metal case, a printed circuit assembly is fastened, on the right side of which radio frequency components are fixed. Thermal power of 7 watt is being uniformly dissipated on the area of the printed circuit assembly. The printed circuit assembly sizes are such that air volumes inside the unit to the left and to the right of the printed block are not communicated. The distance from the left wall of the case up to the printed circuit assembly is equal to 5 mm. At such clearances in the closed vertical layers, air convection does not develop. Hence, this air volume can be related to a thin air layer. In the right part of the unit, at the bottom of the case, the transformer is fixed, dissipating thermal power of 4 watt. Its sizes are length 30 mm, width 30 mm, height 50. Lubricant is used while fastening the transformer. Ambient temperature around the unit is equal to 30 degrees. Thickness of the unit walls is 4 mm. The case of the unit is made of an aluminum alloy. The printed block is made of fiberglass plastic. Its thickness is 2 mm. So we design the model. The unit is conditionally broken into 10 isothermal volumes, to which 10 blocks of the model are put in conformity. First, we design the case model. So let's enter block 1 is the left wall. Similarly, we enter the other 5 walls of the unit. Block 1 we connect with block 2 by the branch heat conduction in the Cartesian coordinate system. We shall enter the sizes determining the section area of the heat flower, that is the section area of the left wall. The size of the left wall is equal to 200 mm, thickness of the left wall 4 mm. The length of the heat flower path is defined as the distance between block 1, the middle of the left wall, and block 2, the middle of the top wall, and is equal to 275. Heat conductivity of the material is taken from the database for the aluminum alloy. Similarly, we connect all the rest walls of the case with each other. Each case side external surface interacts with outside air through convection and radiation. For this purpose, once again, we shall twice set all blocks of the case. Block 1 we connect with block 10 by the branch free convection from the flat undeveloped surface. Parameter of the branch of the left wall: surface length, so it's 300 mm, surface width 200, determining size 300, is taken from the reference book. For vertical plate, factor of orientation is 1, also taken from the reference book. Ambient pressure 760 mm. Similarly, we connect all the rest walls of the case to the block 10. Block 1 we connect with block 10 by the branch emission from the undeveloped surface. Parameter of the branch of the left wall: surface length 300, surface width 200. The emissivity factor and irradiation coefficient are taken from database for the aluminum alloy. Similarly, we connect all other walls of the case to block 10. The right top, front, back, and bottom internal sides of the case are interacting with air inside the unit. Block 2 we connect to block 9. by the branch free convection from the flat undeveloped surface. Parameter of the branch of the top wall, surface length will be 250, surface width 200, the determining size 200, which is taken from the reference book. For a horizontal plate, this is the minimal size. The orientation coefficient is 0.7, also taken from the reference book for the horizontal plate, dispersing the thermal stream downwards. Ambient pressure is 760. Similarly, we connect all the other walls of the case to block 9. The printed unit assembly 7 interacts branch 7 to 1 through flat air layer with the left side of the case. Parameter of the branch, layer length 300, layer width 200, and the layer thickness 5 mm. Branch 7 to 9, free convection from the flat undeveloped surface. Parameter of the branch, surface length 300, surface width 200, and the determining size 300, taken from the reference book for a vertical plate, so it's a height. Orientation coefficient 1, also taken from the reference book for a vertical plate, ambient pressure 760. Branch 7 to 8, radiation with a transformer. Parameters of the branch, the surface 50, surface width 30, surface emissivity and irradiation coefficients are taken from the database. The printed unit by radiation interacts with all walls of the case. Block 1 we connect with block 7 by the branch emission from the undeveloped surface. Parameter of the branch, surface length 300, surface width 200, and surface emissivity and irradiation coefficient are taken from the database. So similarly, we connect all the other walls of the box to block 7. Block 8 transformer we connect with block 9 by the branch free convection from the flat undeveloped surface. The sizes of the equivalent total area of the horizontal plate are taken. Parameters of the branch, surface length 100, surface width 69 mm, and the determining size 69 mm. Orientation coefficient is 1, and ambient pressure 760. Block 8 transformer is combinable with block 4. A branch contact heat resistance. Thus, the total area of the contact through 4 legs is set is equal 100 square millimeters. Perimeter of the branch. Length of the contact spot is 20 millimeters. Width of the contact spot is 5 millimeters, and lubrication factor is 0.8. The block 8 transformer, we shall also connect to blocks 2, 3, 4, 5, and 6 walls of the case by the branch's emission from the undeveloped surface. And perimeter of the branch from A to 2, emission from the undeveloped surface, surface length 30, surface width 30, emissivity factor, and irradiation coefficient we take from the database. Parameters of the other branches are similarly entered. Into block 7, printed unit, we include constant power source equal to 7 watt. And into H transformer, we include constant power source equal to 4 watt. Into block 10, environment, we include constant temperature source of 30 degrees. And then we carry out calculations. As a result of the calculations, we receive the following temperatures at a stationary thermal mode.